Question that we're going to solve today is missing element in sorted array. So in this question, we will be given a sorted array. It wouldn't start from 1, it would start from just any number. And you'll be given a number value for k, which if you look at this example, it is equal to 1. So you have to find the first missing element. So if you go from 4 to 10, the first missing element is 5, so you have to return 5. If you look at this example where k is equal to 3, the first missing element is 5, then 6, and 8. So 8 is the third missing element, so you have to return 8. So now let's look at some of the examples to understand the problem better. So if you look at this example, in the example there's all these numbers that are marked in yellow are the missing ones, and we're looking for the fifth missing element, which in this case would be 15. 1, 2, 3, 4, and 5. So this is the input that we have been given, and this is what the expected array should look like if there were no numbers missing. So what does this represent? If you look at this, if you look at 11, the index that it has is 3 over here, but its expected index actually is 7. And so that means that it's missing 4 numbers on the left, right? That's why it has, instead of being 7, it's actually 3. So this way, and we're looking for k is equal to 5. So we know that the number that we're looking for actually lies on the right side. It doesn't lie on the left because there's only 4 numbers missing on the left. So this way, you can actually divide this search space into half, and the input array is actually already resorted. So this is just ring the bell that we can use binary search, and we are onto something with this. So let's try it out. So if, let's say, this is the mid and we're looking for k is equal to 5, but we check the expected index and we find out that the missing numbers on the left are actually 4, but we're looking for k is equal to 5. So we move our search to the right side. Now we're looking at the right side, and this would be the next mid. The expected index for 13 is 9. So that means that it is still missing 4 numbers on the left, but we're looking for k is equal to 5. So we move to the right side. Then the next mid would be 14. Its expected index is 10. That means 4 number missing on the left. So we still have to go to the right. So we go to the right and we check the index. Now we see that there's exactly 5 numbers missing on the left. So the number that we're looking for has to lie somewhere between 14 and 16, right? So what did we find out? We found out that depending on the missing numbers, so let's say if at every index we're calculating the number of missing elements on its left, right? So if missing number is if it is smaller than k, then we move our search to the right side. And if missing number, that is for sure, that is how we've been searching so far. So if missing number is greater than k, then we move our search to the left side. That is known for sure. Now we want to see what do we do if the missing number, the number of missing elements is exactly the same, like in this case, right? The k was exactly equal to 5. What do we do? Do we stop there? Do we continue our search? What do we do? So let's look at another example to clear that out. Let me just clear this out. Okay, so let's look at another example. If, let's say, we have an example something like 6, 7, 10, 11, 19, 21, 23, and we're looking for k is equal to 2. If we write down, let's write down the indexes as well, 2, 3, 4, 5, and 6. And we write down what the array should actually look like. So if there were no missing elements, then that would be 8, 9, and then 10, 11, 12, and so on. I wouldn't write all the numbers on the right because our search is anyway going to be on the left side. So 1, 2, 3, 4, 5, and 6. And we're looking for the number 9 because we're looking for k is equal to 2. So when we start our binary search, we would end up here. This would be the mid. We'll check that for 11, it is actually, there's exactly 2 numbers missing on the left, which is correct. But what should the number be then? Where should our search go? We don't want to return out from here because if you see for 10, it gives the same value, that there's 2 numbers missing on the left. So we have to continue our search and move to the left in case the missing number is equal to k. So we go to the left side. So when we go to the left side, in that case, then the mid would become 7. We check for 7, it is exactly this. There's no missing numbers here. So we move to the right again. When we move to the right, we would come here. And this is where, so our search has narrowed down to this number. And it is still equal to k, but we cannot move anywhere else. So low will cross high in this case. And then we'll come out. So we would stop our search over here. So what we learned so far is, in addition to these conditions, we want to move to the left also when k is equal to, missing number is equal to, the number of missing elements is exactly equal to k. Then also we want to keep moving to the left because we want to keep looking for the lowest number that'll give the results. When 10 and 11 are giving you the same numbers, even for 12, if you look, it's going to, if 12 was involved here, it would give you that there's only 2 elements missing on the left if 12 was in this array. Then we want to keep moving to the left. So this is what we've found out so far. Now, one thing we want to look at is how do we find the expected index? That's one thing that we want to know, right? We don't want to create an array to find the expected index. So because everywhere we were comparing, right? We were checking what should be the index for 11. So if you look at this, the way to find out the expected index is actually pretty straightforward because you're expecting the index for 10 to be 4. So for that, you can just do this, that the expected index would be equal to whatever the start number is. So the expected index would just be equal to whatever number the mid is representing. So whatever number is on the mid minus the start number, whatever is the number on the start. So this is a little tricky example, but let's see. So if we are at 11, what is the index that we expected to have? We expected to have index 5. How do we come out with that? So you just take the number that is here and you subtract it with 6, right? What would it give you? 11 minus 6 would give you 5. That is the index that you're looking for. If you're at 10, you're expecting the index to be 10 minus 6, which is 4. So the expected index can just be found out like that. Whatever number you're reading, you just subtract it with the start number, the beginning number, because that is the range, right? It would have been 1, 2, 3, 4, 5 in front of it. So if that's not the case, then you just subtract the number with the starting number, and that will give you the expected index if there were no elements missing in the given input array to you. So that is how we find out the expected index. So we know how to move our search from left to right in case while comparing the missing numbers with k, and we know how to find out the expected index. Now the last thing that we want to look at, what happens because this is a corner, these are the corner cases that we're going to run into. So the last thing that we want to look at is what exactly do we return from here, right? Because when we're done, once the search crosses, your low crosses your high and you come out, mid is going to be pointing to a particular number, but what do you return from your binary search? So there's going to be 2-3 cases here. One is going to be that either when you come out, your missing number is going to be either exactly equal to k, or it's going to be greater than k, or it's going to be smaller than k, right? When you come out of the search, when your low has crossed the high. So you came out of the binary search. So these are the three cases that's going to be there. So what do you want to return in the end? So let's look at a few examples for that. So let's say if we have 1, 2, 4, and k is equal to 3. So you're looking for, there's only one missing number over here, right? There's only 3 missing over here. In this case, your k is actually greater than the number of missing numbers, because when you do your binary search, you would actually be pointing to this, right? Let's see. Let's see, what would it look like? 1, 2, 3, and 4. So these would have indexes 1, 2, 3, and this would have index 1, 2, 0, 1, and 2. So in this case, when you come at, so you'll come at 1 and it has the same index as expected. So you move your search to the right, you come to 4 and you see that it has the index 3. There's only one missing number on the left, which is 3. So you want to move to the right. So, but when you come out, your mid is going to be pointing to 2. So after coming out, actually missing number is going to be, the number of missing elements on the left is just going to be 1. But k is smaller than k. K is 3, right? So in that case, what do you want to return? The number obviously lies on the right. It's not included in the array. So what do you want to return in that case? Just the number of the mid plus, so whatever this is, number on the mid. So let's just write it down, or we can cover it up in the code. So what we want to do is we want to add 4. It has to be up. It has to come after 4, right? So 4 plus k minus missing numbers. What does that give you? It gives you 3 minus, and what is the answer in this case, right? So the answer in this case is 6. We're looking for 6 because 3 is the first missing element, then 5 and 6. So we're looking for 6. So you want to subtract k, and the missing number is actually 1. So what does that give you? Gives you 4 plus 3 minus 1, 6, because you want to move to the next, this thing, right? So this is pretty straightforward. The number is going to be ahead of it. So you just subtract. It's going to be, if there's only one missing element at this place, and you just want to find the second number that comes after this, or because k is equal to 3. So the second number that comes after 4, which can just be found by k minus the missing number at that index. So that will give you 6. So this is one case where if missing number is smaller than k, so you want to do this. What do you want to do if it's equal to or greater than k? Let's see. So let's look at one more example, I think. And that should cover the, I don't want to cover the third case of equal to as well, or let's see, whichever one, whatever condition the next example covers actually. So let's see, 70, 90, 100, 200, and 500. So 0, 1, 2, 3, 4. If the input array is something like this and you're looking for k is equal to 10, we've already covered where missing numbers is smaller than k. So we're trying to look at k is equal to, k is greater, missing number is greater than k. So k is 10. There's already 19 missing numbers in between this range, if you see. So first we would come here. I don't want to write the expected indexes. So first you would come here, and then of course you're going to move to the left. So when you move to the left, you would go to 10, 70. But at 70, you're looking in this range. But at 70, there's no missing number. So you move to the right. And so finally, you would actually come out at 90 here, right? And when you come out at 90, the missing numbers for 19, the mid is going to be pointing to 90, and the missing numbers in this case is going to be 19. But you're looking for k is equal to 10. So basically, your missing numbers is greater than 10 after coming out. So this is the case we're looking for. It is greater than 10. So what do you want to return in that case? So if you see, we basically just want to return whatever is the number pointed out by the mid, which is going to be 19, plus k minus the missing numbers. So k is actually, in this case, 10. So you want to do minus the missing numbers, and the missing numbers is actually 19. So what does this give you? This gives you negative 9, right? So that would be 19. Oh, I'm sorry, it's actually 90. You're looking at the mid. So 90 plus k minus the missing numbers, which would be minus 9. So it would give you 81. Right? But you also want to do minus 1 over here. So that is the catch in this one. So that is the only difference. If what would be the 10th missing number from this? It would actually be and you just want to subtract minus 1 from it. So you'll do minus 1, minus 1, minus 1, and this will give you 80. That is the answer. So in case, if it is, in these two cases, if it's greater than or equal to k, you want to just do this one extra step of just subtracting 1 from it. So I think we've figured everything else out. We know how to move to either left or the right side. We know how to find the expected index. We know what to return in case the missing number is equal to k, greater or smaller than k. So now we can look at the code. So of course, first we need the start number to find out the expected index, right? So which is going to be nums of 0, and the size of the nums is always going to be at least, there's always going to be at least one element, so we don't have to worry about that. Now for our binary search, low is going to be 0, high is going to be nums dot length minus 1. We want to have mid, let's set it to 0, and we want to have the missing numbers also, right, on the left. So let's say missing numbers, let's set it to 0 in the beginning, and we also want to have the expected index. So expected index, let's set it to 0 in the beginning. So I think we got all the variables that we need covered over here. Now let's just start the binary search. So while low is smaller than or equal to high. Okay, so first of course we have to find the mid, which is going to be low plus high minus low divided by 2. So we have the mid. Now we want to have the expected index, and we talked about how we're going to find the expected index, right? So expected index is going to be equal to nums of whatever the value of the element is minus the start index. So that is how you find out the expected index. Now we want to find out what are the missing numbers on the left, the number of missing elements on the left. So missing numbers is going to be equal to the expected index minus actually whatever the index it really has at this point, right? So which is going to be mid. So this is the missing numbers on the left. Now we want to move from either left or right depending on the missing numbers and compare them to k. And we found out that if missing numbers is greater than or equal to k, then we want to move our search towards the left, so mid minus 1. Else we want to move our low to mid plus 1, right? That's pretty clear. We actually discussed the scenarios of when and how to move to either left or right. Now when you're done with the binary search, we discussed what values we're going to give back depending on the missing numbers that we calculated in the end and the number that is represented by the mid, right? So if it is going to be smaller than k, then we discussed that we are just going to return nums of mid plus k minus whatever missing numbers we calculated at that point, right? This example. So we just want to do mid, in that case was 4, and missing number for at this point was just 1. We wanted k is equal to 3, so k minus missing number gives us 2, so we just return 4 plus 2. This is the case. Else, if it is equal to k or greater than k, we discussed that we want to return -1, append -1 to this, so that is going to give you the correct answer in this case. So we just want to do -1 in this case. So I think this is it. Let's try running it. Minus start index. Oh, it's not start index, it's start number. Let's try to run all the test cases. Let's submit. That is pretty good, I would say. Of course, the time complexity is just logN, and the space complexity of O of 1 is O of 1 because you're not storing anything anywhere. I hope that helped you guys. Have a good day.